Welcome to This Explainer. When we think of AI, we usually picture something invisible, right? Something weightless, just living up there in the cloud. But here's the thing. The cloud is incredibly heavy, and it is incredibly hungry. Today, we're looking past the software and exposing the massive physical reality of artificial intelligence. Because what we're about to explore, it's literally the biggest industrial challenge of the next 20 years. So, let me ask you something. Right now, what do you think is the absolute biggest threat to the AI revolution? You might immediately think of software bugs, right? Or maybe running out of training data. Or, of course, a shortage of those super expensive microchips. But actually, the real answer is way more foundational. It's something we've just completely taken for granted for about a century.
It isn't a microchip shortage, it's the power grid. That's right, the power grid. AI's true limitation isn't digital at all, it's physical electricity and the aging wires that carry it. Think about it. A data center can have billions in funding, the perfect plot of land, brilliant engineers, all the GPUs in the world, and it will still be completely useless if the electrical infrastructure can't get there fast enough. We're talking about a massive paradigm shift here. AI capacity doesn't exist when GPUs are ordered, it only exists when power is actually delivered.
So, here's our roadmap for this explainer. First, we'll cover the AI power surge, then the infrastructure bottleneck. After that, firing up fossil fuels, followed by the nuclear AI future, and finally, rewiring America's grid rules. Let's jump right in. Starting off with Section 1, the AI power surge. To really grasp the sheer scale of this surge, you have to understand that modern AI data centers are pulling upwards of 80 megawatts each, and there are facilities planned right now that will exceed 1 gigawatt. To put that into perspective, that is enough to power an entire medium-sized city, just for one facility. Because this is such uncharted territory, forecasters are kind of all over the place. Goldman Sachs predicts a jump to 400 terawatt-hours by 2030. That's a massive unit of energy, literally a trillion watt-hours. Wells Fargo, they estimate an even higher 652 terawatt-hours. The consensus across the board is pretty clear. The surge is going to be absolutely astronomical. Just let this number sink in for a second. 8,050%. No, that's not a typo. That is the jaw-dropping growth rate and power consumption specifically from AI that Wells Fargo is projecting between 2024 and 2030. Going from 8 terawatt-hours up to a staggering 652. The electrical grid simply was not built to absorb an 8,000% increase in demand from one single concentrated sector in just 6 years. It's wild. Which brings us to Section 2, the infrastructure bottleneck. Because generating the power, that's really only half the battle. You have to physically move it. And this is exactly where lightning-fast AI slams right into heavy industry. On one side, you have digital innovation. New AI models are being deployed in literally a matter of weeks. But on the other side, physical reality. If you want to connect a hyperscale data center to the grid, you need these massive industrial power transformers, and the average U.S. delivery time for those just hit 143 weeks. Yeah, that is nearly 3 years you're spending just waiting for the equipment to distribute the power. And honestly, even when you finally get the equipment, you still have to wait in line. 5 years. That was the median wait time in 2023 just to get off the grid's interconnection waiting list and begin commercial operation. 5 years. With over 2,500 gigawatts of capacity currently sitting in this backlog, you can see how this is a massive hurdle for hyperscale AI campuses. And it's creating these cascading supply chain shortages across the entire electrical stack. It's not just transformers that are delayed. We're seeing a 40% shortage for high-voltage switchgear, which are essentially the giant traffic cops for electricity on the grid, plus a 25% shortage for breakers and a 20% shortage for medium-voltage switchgear. And underpinning all of this, copper. The real bottleneck for the future of tech isn't code. It is heavy, metallic, and incredibly physical. Okay, moving on to Section 3, firing up fossil fuels. So what do you actually do if you're a tech giant racing to deploy AI right now? Well, you look backward. Despite all these ambitious green goals, there is a deep, deep irony here. The most advanced technology in human history is largely running on natural gas and 19th century coal. When we look at U.S. data center energy sources, natural gas makes up 40%. Renewables account for 24%, but because the wind doesn't always blow and the sun doesn't always shine, they just can't provide that flat 24/7 steady power that AI constantly demands. The rest is nuclear at 20% and coal at 15%. To bypass those massive grid delays we talked about, tech companies are increasingly building what's called behind-the-meter power.
Basically, they're setting up their own off-grid natural gas plants directly on site. Problem solved, right? Well, meanwhile, the surging demand is also forcing utilities to halt the retirement of old coal facilities and peaker plants, which are these really dirty facilities meant to only run during peak emergencies. Right now, the priority is just raw power, by absolutely any means necessary.
This leads us perfectly into Section 4, the nuclear AI future.
Now, big tech knows fossil fuels aren't a sustainable long-term strategy. The key to their futuristic zero-carbon fix is something called the SMR, the Small Modular Reactor. Unlike massive traditional nuclear plants that literally take decades to build, SMRs are compact. They generate between 50 and 300 megawatts, which means they can be manufactured in parts, scaled up, and co-located right next to a data center. That gives them steady, 24/7, carbon-free power. It's kind of a huge game changer.
And we are already seeing the major hyperscalers place massive bets on this tech. Just look at the timeline. In late 2024, Amazon partnered with X-Energy and Dominion Energy. Google also announced a major partnership with Kairos Power, and their goal is to deliver 500 megawatts of SMR power specifically for their AI and cloud operations by 2035. So the tech industry is essentially stepping up and acting as the first-mover commercial base to jumpstart the next generation of the nuclear energy industry.
And finally, Section 5, Rewiring America's Grid Rules.
You see, this gridlock isn't just a corporate problem anymore. It's widely recognized as a matter of both economic and national security. The Biden-Harris administration has basically identified that maintaining U.S. leadership in frontier AI requires untangling this whole mess. So they've deployed historic national security memos and executive orders designed to speed up permits, open up federally owned sites, and mobilize agencies to adapt to this new reality.
The regulatory hammer being applied here is sweeping. The Federal Energy Regulatory Commission, or FERC, has actually ordered regional grid operators to create much faster connection processes for data centers. They're even allowing direct connections to power plants in some cases. Major regional operators like PJM and Texas's ERCOT have been formally directed to streamline large load requests. There are even categorical exclusions for transmission lines. The government is even exploring fast-tracking interconnections at retired coal sites, all to ensure AI supremacy. It's a huge push from the top down.
But these national ambitions are colliding head-on with local reality. Right now, 80% of U.S. data centers are concentrated in just 15 states. That creates immense localized strain. So while federal policies are pushing for speed, local utilities are being forced to make massive, insanely expensive upgrades to their infrastructure just to handle these new hyperscale facilities. And this kind of localized concentration raises a really critical concern regarding who actually pays for these upgrades.
Which leaves us with this final, crucial question. As the AI arms race triggers the biggest grid upgrade we have seen in decades, who is actually going to foot the bill? Are the tech giants going to bear the full cost of the infrastructure they're demanding, or will the multi-billion-dollar price tags for new transmission lines and substations just trickle down to the monthly electric bills of everyday residential consumers? The physical reality of AI is here. It's heavy, and it is expensive. The software might be free to use today, but the power behind it, it certainly isn't. Thanks for joining me on this explainer, and I'll